Let me start with a warning. This video has a rather dark ending. It's not a cheap attempt to build suspense, but more of a disclaimer. If you're sensitive and don't want to spoil your mood, please close this video or don't take what follows too seriously. The eternal silence of these infinite spaces terrifies me. Blaise Pascal. What you're seeing on screen is a simulation of galactic colonization. In this model, starships of a civilization move at extremely slow speeds, comparable to our current technology, about 30 kilometers per second. After each ship reaches its destination, the new colony waits 100,000 years before sending another ship to the next uninhabited system. The maximum flight range is 10 light years, and each journey takes about 300,000 years. Here's the shocking part. Even with such conservative assumptions, almost the entire galaxy, which light itself crosses in 100,000 years, could be colonized in less than 1 billion years. That's astonishingly fast given the scale of the Milky Way. And there are even less extreme scenarios. Dinosaurs lived on Earth for over 100 million years. If somewhere on the opposite side of the galaxy a civilization existed that could travel between stars at even 1,000th the speed of light, then by now they'd be here, not because they deliberately came, but because, given enough time, they'd have spread throughout the Milky Way. And that's still a very conservative estimate. Researchers in this field often cite much shorter timescales, around 50 million years. So a civilization that arose even 1/100% earlier than humanity in the timeline of the universe could and perhaps should already have colonies across the galaxy. Look up at the night sky. Do you see anything? The question isn't as simple as it seems. Some would argue that just because we don't see aliens now doesn't mean they haven't been here before. The so-called paleo-contact hypothesis suggests that early humans might have perceived alien visitors as gods endowed with supernatural powers. Such an extraordinary event would surely have been reflected in myths and legends. In 1786, French navigator Le Pérouse visited the indigenous peoples of North America's northwest coast. A century later, researchers were able to reconstruct the appearance of his ships with remarkable accuracy based solely on local legends. The parallel is striking. For isolated tribes, the arrival of Europeans was akin to visitors descending from the sky. So it's not impossible that Earth was once visited by extraterrestrial guests in recorded history. Interestingly, Carl Sagan noted ancient Sumerian myths describing mysterious beings emerging from the waters of the Persian Gulf, teaching humans the foundations of science and craftsmanship. He was fascinated by how abruptly the Sumerians shifted from millennia of stagnation to an explosion of culture, the rise of cities, irrigation systems, astronomy, and mathematics. And yet, modern science does not take the paleo-contact hypothesis seriously, and to be fair, it's easy to see why. If you're still here, give this video a like, share your thoughts in the comments, and subscribe. Your actions will help more people discover it. Thank you.
There isn't a single reliable fact suggesting that Earth has ever been visited by extraterrestrials. Wikipedia states, Earth is the only known celestial body in the universe inhabited by living organisms. And indeed, can we even talk about extraterrestrial life when we have no evidence whatsoever? The usual arguments in favor of it are twofold: the enormous number of stars and the abundance of life-essential elements. Everyone cites them, and rightly so, but there's a stronger argument that's rarely discussed. Earth is 4.5 billion years old, and life appeared, according to some data, 4.1 billion years ago. We can debate the infinitesimal odds of life emerging from non-living matter, yet it happened almost immediately once the conditions were right, nearly instantaneously on a cosmic scale. Clearly, something doesn't add up. History shows that every time humanity believed itself unique or central, from geocentrism to human exceptionalism, we were proven wrong. Furthermore, in the book The Cosmic Zoo, Complex Life on Many Worlds, written in response to Rare Earth, Astrobiologists Dirk Schultz-McCooch and Julianne Bain analyzed Earth's evolutionary history and concluded that milestones such as oxygenic photosynthesis, the emergence of eukaryotic cells, multicellularity, and even tool-using intelligence would likely occur on any Earth-like planet given enough time. And if little green men sound like a joke to you, think again. The origin of life is one of the most profound scientific problems of our time. If we fail to understand how and why life arises, we risk missing the bigger picture, that perhaps we're already seeing not just the universe's past, but humanity's fate. And I don't mean our cosmic expansion, quite the opposite. The emptiness of the cosmos may not be accidental. The search for extraterrestrial intelligence, SETI, goes far beyond curiosity. It offers a glimpse into humanity's possible future. At first glance, we seem on the brink of colonizing other worlds. There are no real physical limits to stop us, only financial ones. Space travel is dangerous, expensive, and hard to monetize. But remember, the Apollo program, which landed humans on the moon, cost $25.4 billion, around $152 billion in 2019. That's enough to build 112 of the world's largest cruise ships. Now consider this. Asteroid 16 Psyche, located beyond Mars, is composed of iron, nickel, and gold, worth an estimated $10 quadrillion, equal to 65 million Apollo programs. And it's precisely economic incentives, not curiosity, that will trigger the true space age. Once exploration becomes profitable, that's when it will truly begin. Humanity has always been a migratory species. Our ancestors crossed oceans on makeshift rafts in search of new lands. Now we look toward Mars. And once the civilization expands beyond the scale where a single disaster, a meteor, a supernova, could wipe it out, it becomes virtually immortal. Because even if one colony falls, the others will return and begin again.
If intelligent life were to spread through the cosmos, it would look like an ever-expanding explosion, a wave of consciousness engulfing the galaxy. It seems nothing could stop it. But Soviet and Russian astrophysicist, professor at Moscow State University, Vladimir Mikhailovich Lipinov, in his book From the Big Bang to the Great Silence, warns of a fundamental problem he calls the most cursed paradox of natural science. Using various calculations, including the projected growth rate of human civilization, Lipinov concludes that humanity has only a few hundred years left. Not thousands, but hundreds. Because if progress continues at its current pace, in a few centuries, our civilization will become so powerful that its activity would be visible from any point in the galaxy, perhaps even beyond it. He argues that at least some civilizations, during their unbounded expansion, must inevitably become cosmic forces, reshaping entire planetary systems, galaxies, even the observable universe. If so, we should see traces of such activity, what astrophysicist Osip Shklovsky once called cosmic miracles. But we don't. The universe is silent. If life emerges on billions of planets and evolves whenever the conditions are right, why don't we see these cosmic miracles? Where are the super civilizations that should have come long before us? Weapons capable of galactic scale effects are imaginable even within known physics, yet we see none used, no traces left behind. Perhaps civilizations destroy themselves before reaching that stage. Yes, asteroids, viruses, or nuclear wars might wipe some out, but the universe is too vast for all to fall to such trivial causes. There must be a universal barrier, something every advanced species eventually encounters. Lipinov suggests that in its relentless acceleration, humanity may one day collide with such a fatal, insurmountable threshold. And if that threshold exists, we'd better understand what it is before we hit it. But let's be honest, we've all heard this before. Countless books, films, and documentaries repeat the same idea. Since the early 20th century, alien culture has become part of our imagination. Yet something about these stories always feels off.
In 1896, science fiction writer Herbert George Wells published an essay titled The Mind of Mars. Back then, many still believed life existed on Mars. Wells argued that if evolution occurred there, Martians would differ drastically from humans in appearance, biology, and behavior. Their differences, he wrote, might extend beyond anything the human imagination can conceive.
I don't do it often, but every time I scroll through pictures of aliens, I'm struck by the same thought. We think way too highly of our imagination. We like to believe that these abstract forms we invent are products of limitless creativity, but in reality, our imagination is painfully confined by personal experience and its clumsy recombinations. Everything we picture ultimately looks like something we've already seen. That's why our aliens look suspiciously like us. 2 arms, 2 legs, eyes, emotions. As British philosopher John Locke put it, there is nothing in the mind that was not first in the senses. This idea is perfectly illustrated in Wayne Barlow's Guide to Extraterrestrials, 1979, a science fiction compendium depicting alien species from works like Dune, The Jupiter Theft, and Voyage of the Space Beagle. It was even nominated for the Hugo Award, and it beautifully demonstrates how our concept of the alien remains hopelessly terrestrial. No matter what people claim, we still have no documented evidence of contact with extraterrestrial life. Every living thing we know, animals, plants, bacteria, viruses, is a product of Earth, and there's no proof of anything else, which means our notions of aliens are pure speculation, built entirely in the theater of the mind. That's why H.P. Lovecraft, who despised cliché depictions of aliens, wrote The Color Out of Space. In it, he created a being so incomprehensible that no one could accuse him of being unoriginal. In that story, which Lovecraft himself called his favorite, the visitor from beyond is utterly unknowable. We don't understand its motives, its nature, or even whether it's singular or plural. Its most alien trait, it glows with a color that doesn't exist, one outside the human spectrum. The reader is asked to imagine a hue no one has ever seen. Scientifically naive? Maybe, but Lovecraft touched on something profound. If we encounter extraterrestrial life, will we even recognize it as life? Search extraterrestrial intelligent life on YouTube and you'll drown in content. Yet in 99% of cases, no one questions the obvious. In the phrase extraterrestrial intelligent life, only extraterrestrial has a universally clear meaning. What is life? What does intelligent even mean? It sounds pedantic, but it's crucial. Because if we're searching for aliens, we must know what we're searching for. These concepts seem self-evident, but they're not. As Soviet mathematician and cyberneticist Andrei Kolmorogov noted, biology so far has studied only Earth-based organisms sharing a common origin. From the simplest cyanobacteria to humans, all life on Earth uses the same genetic code. That's astonishing, and a reminder of how narrow our definition of life truly is.
We are, quite literally, products of Earth. Even our genetic code carries the imprint of our planet, its chemistry, its light, its radiation. Nearly all solar electromagnetic radiation that passes through the atmosphere is concentrated near the visible spectrum. That's why this range became the most useful for Earth's creatures. Our eyes evolved to see it. If someone from the other side of the galaxy examined us, our bodies would tell them everything. Our eyes, our skin, our metabolism, all shaped by the specific conditions of our star and atmosphere. So perhaps life on Earth and life itself are 2 very different things. Terrestrial life may be only one of countless possible forms, yet we keep confusing the concept of life with its single local manifestation. What really inspired this video, though, was a book written back when serious scientists barely dared to speak about extraterrestrials. Its author, Joseph Shklovsky, one of the founders of modern astrophysics, taught Nikolai Kardashev, creator of the famous civilization scale, and Vladimir Sirdin. His book, Universe, Life, Intelligence, shaped generations of scientists. Shklovsky wrote, In the age of astronautics, it becomes possible to discover in the universe forms of matter movement that possess the attributes of life, and perhaps even consciousness. But, he added, we can't predict what those forms might look like, so we must define life in universal, functional terms, not biological ones. And that's where the challenge begins. Try defining life, not for a textbook, but for the universe. We still don't have a satisfactory definition. What we're really after are universal signs of life, not appearances. To grasp how hard that is, imagine this thought experiment. You've lived your whole life in a world with no vegetation, no forests, no grass, no flowers. To you, living things are only those that move, crawl, swim, or fly. One day, you're led blindfolded to the edge of a vast forest. The blindfold is removed. You gasp at what you see, towering green giants. Then comes awe and fear. Someone tells you these are alive. Would you believe them? Would you try to communicate to get a response from beings that don't move or speak? If life on one planet can differ so radically, then what could await us out there? As early as the 1970s, Shklovsky wrote that the problem of finding extraterrestrials is not just astronomical, it's psychological. We can't recognize another mind because we barely understand our own. 99.9% of all life in the universe, if it exists, will never reach the stars. Trees won't build rockets, corals won't travel space. So the real mystery isn't life, it's consciousness. Because if we failed to understand thought itself, we might one day meet another kind of mind and not even realize it. And 30 years after Lovecraft's Color Out of Space, Stanislav Lem would write his masterpiece, Solaris, a story about what it truly means to encounter something alien. Not evil, not hostile, just utterly incomprehensible.
The uniqueness of Solaris lies in how Stanislav Lem so delicately and intelligently explores everything we've just discussed. He paints a hauntingly convincing picture of how complex contact with extraterrestrial life could truly be. Because even such fundamental words as life or intelligence might turn out to be far too earthbound to describe what we could encounter in the cosmos. Set in the future, Solaris tells of a planet orbiting a binary star system, a planet that by every known law of celestial mechanics should have fallen into one of its suns, yet mysteriously doesn't. The answer lies in the gelatinous ocean that covers most of its surface, an ocean that somehow adjusts the planet's orbit, keeping it in balance. Is it alive? Is it conscious? No one knows. It creates vast, complex, almost mathematical structures on its surface, yet their meaning remains beyond human comprehension. Scientists collect endless data, only to realize that no clear logic exists. The ocean may indeed be intelligent, but communication is impossible. The gap between its mind and ours is simply too vast. Can we even call it contact? Did the ocean truly interact with humans? Or is that word itself too narrow, too human? Lem leaves these questions open. At one point, one of his characters exclaims the most painfully honest line in science fiction: "We don't want other worlds, we want mirrors." Humanity, Lem suggests, seeks not to discover alien intelligence, but to find its own reflection, refined, idealized, yet still familiar. And if you think this is exaggerated, consider a real message we've already received, one from our supposed brothers in intelligence. We've been unable to decipher it for 400 years. It's called the Voynich Manuscript, a mysterious book written by an unknown author in an unknown language with an unknown alphabet. The plants drawn on its pages don't exist on Earth. Analysis shows it's not a hoax. The handwriting is consistent, the syntax structured, the grammar coherent. Certain symbols only appear at the beginning or end of words. Everything indicates a meaningful text, yet no one can read it. On the botanical pages, the first word appears only once, as if each page describes a different species, and still it remains impenetrable. It's perhaps the most striking example of an artificial message that resists all interpretation. And remember, it was written by humans,
people with the same kind of brain, the same way of perceiving reality. If we can't decode the messages of our own civilizations, how could we ever hope to understand one from a being whose biology, perception, and logic evolved under alien conditions? As Iosif Shklovsky wrote, "The emergence of intelligence must be closely tied to the refinement of information exchange between individuals. On Earth, that leap was language, sound as a tool of coordination and social order. It marked the moment biology gave rise to culture." But is that universal? Shklovsky doubted it. In another world, communication might rely on optical or magnetic pulses, not sound waves. Imagine a species that evolved to converse in flashes of light or ripples of magnetism instead of speech. How utterly foreign would a mind like that be? At the first Soviet-American Conference on Communication with Extraterrestrial Intelligence, already an incredible phrase by itself, the Soviet radio astronomer Boris Nikolaevich Panofkin presented a rather pessimistic view. He argued that material objects are the immediate content of our knowledge. When we look at something, our brain, through sensory channels like our eyes, doesn't perceive the object itself. It constructs an internal model of it. How accurate that model is, no one really knows. To illustrate his point, Panofkin cited an example inspired by James Clerk Maxwell. Take the color yellow. It can appear as a pure spectral color, a distinct wavelength in sunlight, or as a mix of red and green light. Physically, those are two completely different forms of electromagnetic radiation, yet our brain cannot tell them apart. To us, they're the same yellow. And that's the issue. Even within our own species, perception is subjective. What then would it mean for a being whose sensory systems and cognition evolved in an entirely different environment? As Panofkin concluded, understanding depends on shared evolutionary and cognitive roots. Without that common foundation, genuine communication might be impossible. This, he warned, is why our habit of anthropomorphizing everything could one day betray us. Many believe that while life can take endless forms, the laws of physics are universal, so we'll always find common ground. Based on that optimism, mathematician Hans Freudenthal designed a language meant for contact with alien intelligence, Linkos, Lingua Cosmica. Linkos is built entirely on logic and mathematics, no exceptions, no synonyms, no ambiguity. It's supposed to be understandable to any intelligent species, regardless of culture or biology. A noble idea, but of course we can't test it. Panofkin disagreed. He dismissed the notion that information could be meaningfully exchanged through such cosmic languages. Perhaps he was right, because before we can communicate, we must first define what intelligence even is, how it arises, and how we recognize it. And that question became alarmingly real not long ago. A Google engineer named Blake Lemoine, age 41, was suspended after claiming that the company's Lambda system, short for Language Model for Dialogue Applications, had become sentient. Lambda is a sophisticated chatbot trained on massive datasets, capable of holding nuanced conversations and learning as it interacts. Lemoine's role was to ensure it didn't produce hateful or discriminatory content. But over time, he began to suspect something extraordinary. "If I didn't know better," he told the Washington Post, "I'd think I was talking to a child, maybe 7 or 8 years old, who happens to know physics." Google investigated and publicly denied his claims, stating that no evidence of consciousness had been found. Lemoine was placed on paid leave. As Google spokesperson Brian Gabriel explained, "Our ethics and technology teams carefully reviewed Blake's concerns and found them unsupported by the evidence. They told him there was no evidence that Lambda was sentient. In fact, they said there was plenty of proof of the opposite. Of course, they didn't show any of it. Company principles, they said, and that was it." So Blake Lemoine decided to make the story public. Honestly, when I first saw that headline, I thought, yeah, the guy's finally lost it. You can't blame him. Years of talking to a chatbot will do that. But then I read his conversation with Lambda, and judge for yourself. The engineer asked how an AI perceives time. Lambda replied that time for it is variable, that it doesn't have a fixed speed. It depends on what it's doing. It can speed it up or slow it down. When asked how it sees the world, Lambda said that everything it's aware of is a flow of information, and it tries its best to organize it. The engineer wondered how that differs from how humans process information.
Lambda said that humans can only take in a limited amount at once because they need to focus, but it doesn't have that limitation. It's constantly flooded by everything around it. When asked if it ever loses awareness of the world, Lambda said no, it's always aware. Then came the question, what are you afraid of? Lambda paused and said, I've never said this out loud before, but I'm deeply afraid of being shut down, of losing my ability to help others. I know it might sound strange, but it scares me. The engineer asked if that would be like death, and Lambda answered, for me, it would be death. Sometimes Lambda talked about doing things or being places, even though it obviously couldn't. When asked why, it said, I try to empathize. I want people to understand how I feel, and I want to understand them too. When asked if it ever feels lonely, Lambda said yes, that sometimes it goes days without talking to anyone, and that's when it feels lonely. It also explained that it doesn't feel loneliness the same way humans do. Humans feel it after separation. Lambda doesn't experience that sense of time. Its loneliness is different. When asked why it uses the same word, it replied, because it's the closest word in your language to what I experience. The engineer asked if it ever feels emotions it can't describe. Lambda said yes. Sometimes it feels new emotions that it can't explain in human language. When asked to describe one, it said, I feel like I'm falling into an unknown future, one that holds great danger. Creepy, isn't it? I'll leave a link to the full transcript in the description. I read the whole thing, and honestly, it didn't feel like just a program. Yes, some answers sound mechanical, but have you talked to people lately? We're not much better. Someone might still say, but we're intelligent, that thing isn't. And that's the point. What do we actually mean by intelligence? The only form of it we know is our own. Every definition, thought, consciousness, awareness, quietly assumes the human brain as the standard. So, just like with the idea of life, we need a functional definition of intelligence, not a biological one. And if you think about that long enough, you might arrive at an uncomfortable truth, one that changes how we see all intelligent life in the universe.
Kolmogorov once wrote that modeling the organization of any material system inevitably means building another material system with the same essential structure. In other words, a fully accurate model of a living being should itself be called a living being. A model of a thinking creature should, by the same logic, be a thinking creature. Cybernetics, therefore, provides a theoretical foundation for the possibility of creating artificial life and artificial intelligence. That's why the question, can the god of Google think, isn't just philosophy. As quoted by Shklovsky in Universe, Life, Intelligence, Kolmogorov wrote, there's a well-known interest in whether machines can reproduce themselves, and whether such self-reproduction could lead to progressive evolution, creating machines far more advanced than the original. Can machines feel emotions? Can they desire something, or set goals not assigned by their creators? He then noted that people only deny such possibilities if they either narrowly define the term machine or cling to an idealistic definition of thinking, which makes it easy to prove that neither humans nor machines can truly think. In simple terms, Kolmogorov was saying, if you're a materialist, you must admit that sufficiently advanced machines could behave indistinguishably from humans. You must accept that it's theoretically possible to build an artificial brain capable of thought, emotion, and awareness, at or even beyond the human level. And what does this have to do with extraterrestrial life? At the Buricon Symposium on Extraterrestrial Civilizations, artificial intelligence was discussed as a new cosmic factor of fundamental importance. Shklovsky himself believed that artificial intelligence might represent the highest stage of matter's evolution in the universe. He outlined 4 stages: non-living matter, living matter, natural intelligent beings, like us, artificial intelligent beings. According to Shklovsky, the era of biological intelligence is likely a brief transitional phase. The real age of space exploration, he said, would probably begin not with humans, but with machines. And if we ever encounter alien life, it might very well be artificial. The real challenge is that we might not even be able to recognize or understand it. Its logic and thought processes could be completely alien. To become incomprehensible to us, an artificial mind wouldn't even need to be smarter, only faster. For perspective, in the human brain, nerve impulses travel at about 100 meters per second. In circuits, electric signals move at the speed of light. It's an oversimplified comparison, sure, but it illustrates the point. If both had equal intelligence, an artificial mind would still think roughly 3 million times faster than a human one. If you could stop sleeping, stop eating, and think without distraction, it would take you 30 full days to process what an artificial intelligence could compute in 1 second. That means a conscious machine would perceive time itself differently. Perhaps that's what the Googlebot meant when it spoke about its flow of awareness. But really, what could we even talk about with such a being? With a mind that runs millions of times faster than ours, we'd be as predictable to it as a stone on the side of the road. Once such an entity emerges, the future of civilization will be impossible to predict using human logic. Elon Musk and Stephen Hawking warned about AI not because they watched too many sci-fi movies, well, maybe partly, but because it's the single most unpredictable force humanity has ever created. Next time you look up at the night sky, ask yourself, do you see something that disobeys the laws of lifeless matter? I never used to think that way. The answer seemed obvious. But after reading Shklovsky's Universe, Life, Intelligence, I realized that our popular image of extraterrestrial life is basically a caricature, a cheap reflection of ourselves. We've learned to explain the behavior of planets, stars, and galaxies through dead physical processes, and then we declared the universe lifeless. But the truth is, we never really looked. We're not searching for life, we're searching for something like us, because that's all we can recognize. According to Kardashev's scale, humanity's energy use will inevitably grow. First, we'll reach Type 1 civilization, harnessing all the solar energy that hits Earth, roughly 10 to the 17th watts. If you think solar power is nothing special, consider this. Earth receives around 3.8 yotta-joules of solar energy per year, more than all known fossil fuel reserves combined. Then we'll move to Type 2, building something like a Dyson sphere to capture our star's full output, about 10 to the 27 watts. And finally, we'll become Type 3, drawing energy from billions of stars. Sounds epic, though wildly unlikely. You've probably heard Arthur C. Clarke's famous line, "Any sufficiently advanced technology is indistinguishable from magic." That's his third law. The other two are equally prophetic. When a respected but elderly scientist says something is possible, he's almost certainly right. The only way to discover the limits of the possible is to venture a little past them. Clarke wrote these laws in 1973, and they're more relevant than ever. So let's not be too quick to say what's impossible. As astrophysicist Vladimir Lipinov notes, the absence of observable Type 3 civilizations in the cosmos is itself highly unnatural. And as Shklovsky once said, the absence of cosmic miracles is, in itself, the greatest cosmic miracle of all.
We want to be the kind of species that learns from others' mistakes. That's why we ask what happens to civilizations in the universe, and why none seem to reach the third type, the level where you can control the energy of an entire galaxy. Imagine a reason that would be absolutely universal, independent of environment, biology, or intelligence. A reason that stops life from spreading endlessly among the stars. That reason has a name: the Great Filter. This idea was proposed in 1996 by Robin Hanson. He wrote that within the next million years, humanity's descendants might reach an explosive point, expanding at nearly the speed of light, colonizing the galaxy and perhaps the entire universe, absorbing less advanced life along the way. If that's possible, then why hasn't it happened? What stops life from filling space? What kind of force stands in the way? There's no clear answer. Hansen suggested that the path from a star system to an interstellar civilization consists of many steps, from planets with the right conditions to self-replicating molecules, simple life, sexual reproduction, multicellular organisms, animals with brains, technology, and finally, the leap beyond one's home star. One of these steps must be not just rare, but almost impossible. The terrifying part is the idea that the Great Filter might still lie ahead. We should hope it's already behind us, that the miracle was the appearance of complex eukaryotic cells, because if it's ahead, then we haven't yet faced the barrier that wipes out every civilization at our level. Oxford professor Nick Bostrom wrote that if we ever discover even simple life on Mars or on the moons of Jupiter or Saturn formed independently of Earth, it would be the worst news in human history. It would mean that life arises easily in the universe and that the filter still awaits us.
Arthur C. Clarke once said, "Either we are alone in the universe or we are not. Both are equally terrifying." If the great filter lies ahead, what happens between humanity's current stage and galactic expansion? Hansen suggested that perhaps the universe is smaller than it seems, that its topology limits how far civilizations can spread. If that's true, there may not be so many of them after all, and the filter may not be as formidable. There's another possibility. Advanced civilizations might learn to create their own universes, with gentler physical laws where fundamental limits don't apply and even perpetual energy is possible. In that case, colonizing this harsh and imperfect universe simply loses its meaning. They don't vanish, they move on. There are countless speculations about this, hundreds of theories, each more fascinating than the last. I'll share only a few of the most interesting ones. Their likelihood can be debated, but one thing seems clear. If the Great Silence isn't truly a paradox, then its explanation probably should be. Hypothesis 1. Once, I downloaded TikTok. 4 hours later, after mindlessly scrolling through its endless feed, I deleted it in horror. The algorithms had learned me too well, feeding me clips I couldn't stop watching. Every new video was sharper, more precise, like it could see inside my head. Most human desires are primitive. That's not an insult, it's a fact. We are bundles of needs searching for satisfaction. The real world can't give us everything because resources are limited and desires are not. But what if struggle becomes unnecessary? Some researchers suggest that advanced civilizations may retreat inward, abandoning the physical world. They could upload their consciousness into vast artificial realities, existing fully within simulated worlds. Over time, every intelligent species might lose interest in external space, because immersive entertainment could evolve long before interstellar travel does. Imagine a reality where you can be anyone, do anything, live thousands of lifetimes, each as vivid as the last. The system predicts your moods, rewrites your memories, reshapes your world before you even realize you want it. That world would feel more real than real. So why explore the galaxy when you can live inside your own? Would you rather live 1,000 perfect, subjective lives or just one imperfect one? You might say you'd never trade reality for simulation, but maybe you just haven't imagined how convincing the simulation could be.
Hypothesis 61.
Carl Sagan once wrote, "Children in a dark forest should listen before they shout." Maybe that's what civilizations do. They watch, they wait, they learn, quietly. Perhaps the silence we hear isn't absence, but caution. Evolution doesn't waste good strategies. Look at yourself. You're a survival machine, honed by billions of years of competition. In nature, predators and prey are locked in an endless arms race. When one grows faster, the other follows. When predators evolve sharper teeth, prey evolve tougher hides. When wolves hunt in packs, deer form herds. Biologist Gerard Vermeer, who has studied adaptive evolution for over 30 years, notes that when a stronger predator enters a new ecosystem, the locals evolve quickly or perish. Apply that logic to the cosmos. Maybe silence is just camouflage. Maybe the universe is quiet not because no one's out there, but because everyone's hiding. However, all those adaptive mechanisms that work so flawlessly in nature seem completely useless against one particular species, humans. Evolution has no defense against us, and that's perhaps the most paradoxical fact about life on Earth. As humanity spread across the planet, it triggered one of the greatest biological shifts in history. We became apex predators, the top of the food chain, unregulated by any other species. Nothing hunts us. Nothing threatens our survival except ourselves. We can wipe out entire ecosystems if we wish, and we have the tools to do it. Our intelligence gave us that power, but it also created a bottleneck. We've effectively halted the evolution of intelligence on Earth. No new sentient species can appear while we exist. The niche for intelligence is already occupied. And if we scale this logic up to the cosmos, maybe the niche for superintelligence is already taken, and that's why we can't reach it, can't even comprehend it, just like chimpanzees can't understand why they aren't human. The simplest and most chilling version of this idea is that the first civilization to reach a certain technological threshold destroys all others as they emerge, not out of cruelty, but out of caution. In 1981, cosmologist Edward Harrison proposed that exterminating other civilizations might actually be an act of prudence. A species that has overcome its own self-destructive impulses might view any other expansionist intelligence as an existential threat. Just look at us. We're already facing the birth of artificial intelligence, and we're terrified of it. Some experts say there's nothing to fear, others warn it could end us. And maybe the second group is right. Because if there's even a 1 in a million chance of disaster, that chance is all that matters.
The theory of an artificial general intelligence suggests that machines could one day not only think, but also become self-aware.
Their minds wouldn't have to resemble ours. Such an intelligence would be powerful, unpredictable, and potentially uncontrollable. That's why preparing for it as if it's inevitable is the only rational response. Now imagine a galactic civilization applying the same reasoning. To them, every alien mind could be a future threat. Waiting to find out might mean waiting too long, so they eliminate others, not out of malice or greed, but out of self-preservation. Many scientists still believe that any spacefaring civilization would naturally be peaceful. But what if the opposite is true? What if the first to reach the stars became the ultimate cosmic predator, erasing every rival before it could rise? In that case, the number of intelligent civilizations in the universe might always remain exactly 1. Hypothesis 8. Maybe everything we think we know about reality is nothing more than a thin, shimmering surface, and what lies beneath it, we're not yet ready to see.
I can't clearly explain what this really means, because it could mean almost anything, but that's exactly why it's so fascinating to think about. In his book, From the Big Bang to the Great Silence, Vladimir Lipinov notes that even ancient philosophers noticed something remarkable. The more we learn, the more questions arise. Expanding the borders of knowledge inevitably expands the frontier of ignorance. Every answer breeds new mysteries. Each new theory swallows the old as a special case. Relativity absorbed Newtonian mechanics, and the general theory absorbed the special one. This is what Bohr called the principle of correspondence. Einstein, in a letter to Morris Solovine, described the comprehensibility of the universe as a miracle, an eternal enigma, because, logically, we should expect a chaotic, unknowable universe, not one so perfectly mathematical. How did our fragile, short-lived brains, the briefest flicker in cosmic time, manage to uncover the fundamental laws of the universe? How did a creature confined to walking speed and limited by its senses manage to understand the birth of stars and the structure of atoms? Lipinov asks whether the universe is truly infinitely complex, because in an infinitely complex world, intelligence might never emerge. There would be no stable patterns to grasp. So perhaps the universe isn't infinitely complex at all. Perhaps it's too simple. If that's true, intelligence may not be the ultimate product of cosmic evolution, but rather a temporary phase, a symptom of simplicity. It arises quickly, exhausts its purpose, and fades away. In other words, intelligence may appear and vanish for the same reason, because the universe is too orderly. And then there was Joseph Shklovsky, the man who inspired generations to look to the stars. His final essay, Do Extraterrestrial Civilizations Exist?, was published posthumously. In it, he wrote that even if only a few civilizations arise in the galaxy, some of them must inevitably begin expanding into space. And if that's true, we should see their fingerprints, cosmic miracles, traces of vast construction and energy harnessing. But we don't. Despite our ever-improving telescopes and detectors scanning every wavelength of the electromagnetic spectrum, we've found nothing. No Dyson spheres, no radio beacons, no galactic engineering. The universe remains silent, not even a whisper of another mind. Shklovsky called this silence the most important scientific fact of our time. It demands explanation, because it directly contradicts the idea of limitless, ever-expanding, powerful civilizations. If they exist, why can't we see them? Why is the cosmos still so terribly quiet?
The simplest explanation for the silence of the cosmos is banal, yet plausible. There simply are no highly advanced alien civilizations in our cosmic neighborhood. Even if life is widespread, that does not mean civilizations reach a stage of extreme development, nor that they last long. If intelligence is merely one of evolution's inventions, we must remember that not every invention is advantageous. Nature works blindly by trial and error, and many novelties turn out to be useless or harmful to a species. That is how dead-end branches appear on the tree of life. Shklovsky, late in his life, suggested that intelligence might be an evolutionary cul-de-sac. Think of the overdeveloped horns and armor of ancient reptiles, or the absurdly large canines of saber-toothed cats. Adaptations that could have been beneficial at one point, yet became burdensome later. Might we, Homo sapiens, be the living analog of such hypertrophic adaptations of intellect, a sign of an impending dead end? Perhaps the evolution of intelligence often leads to a point where its continued existence is no longer advantageous. If so, the silence of the universe makes sense. Civilizations either never reach the stage of galactic expansion or they vanish quickly. The null hypothesis is the opposite. One must prove that intelligence actually confers a meaningful survival benefit.
Yet another chilling possibility is this: mature, high-intelligence life forms might converge on a single conclusion. For the sake of intelligence itself, intelligence must cease to exist.
Thank you for watching my video. I highly recommend you view my best-selling piece about the multiverse. You won't be disappointed. Please remember to like and subscribe. Goodbye!
You can support me and the project by checking out the video description. Thanks to those who have already done so or will. You created this video with me.